Really excited to talk with you all about recent results from NASA's newest flagship mission to Mars. This is the Mars 2020 Perseverance rover, and it is currently exploring the surface of Mars in a place called Jezero Crater, and I'll talk a little bit about that location and why it's so special and why we chose to send this rover to that place. But I wanted to start off with one of my favorite images from the mission so far, and this is a GIF here showing the Perseverance rover. But also in the background there, we have the helicopter. This is the Ingenuity helicopter, the little buddy that rode along with Perseverance on its journey to Mars. And here we have Perseverance doing a side-eye look over to the helicopter. And so we take selfies with the Curiosity rover all the time. But Perseverance upped the game a little bit by getting the helicopter in that view as well. So this is a great image that we got, and it's just incredible for me to see these two spacecraft on the surface of Mars, because the last time I saw them, they were in the big clean room at JPL, and here they are on the surface of Mars together. So that's a great image and really exciting for me. So I'm going to tell you a little bit about the mission. I'll give an overview and then show some recent results and tell you where we're headed next with the rover. So I'll start off here. We have sent a number of rovers and landers to the surface of Mars. And so this is kind of a fun graphic showing the evolution of a Martian, starting with the Pathfinder mission and the Sojourner rover here. And then you may be familiar with Spirit and Opportunity, the twin rovers that were exploring Mars for many years, way outlived their expected lifetime. And they were smaller and solar-powered rovers, but then we transitioned into the bigger rovers with Curiosity, which landed on the surface of Mars in 2012 and is exploring a place called Jezero Crater and has found a lot of exciting things in Gale and come to understand habitability on the surface of Mars. So the ability for Mars to support ancient life. And next in that evolution was the Perseverance rover. And Perseverance is really exciting as a mission because it is the first step of a potential Mars sample return campaign. So an effort to bring samples from Mars back to Earth. And all of these missions, Perseverance included, are progressing towards human exploration of Mars. And so that we kind of show that next in line here. But each mission has made an advance in that direction with the ultimate goal of humans setting foot on the surface of Mars. And so I'll share a little bit about what Perseverance is doing to advance that goal of human exploration elsewhere in the solar system. All right, so the mission has 4 main objectives, and this is pretty common for NASA missions. We call them the ABCD objectives. Similar to the Curiosity rover, Perseverance is seeking to understand the geology of its landing site. What are the rocks there? How are they formed? What ancient environments do these rocks represent? And so that's a common goal for Mars rovers, and Perseverance is the same. But where Perseverance takes kind of the next step in understanding the science and astrobiological potential of Mars is in Objective B, which is seeking signs of ancient life on the surface of Mars. And we have a payload that I'll talk a little bit about the instruments on the rover that are really well suited and the best suited, I think, of any Mars rover to search for signs of ancient life on Mars. And Objectives A and B, understanding the rocks and seeking signs of ancient life, feed into Objective C, which is sample caching. So Perseverance, as I mentioned, is the first step in Mars sample return. And so the idea is for Perseverance to study the area that it's exploring and select and collect samples to put into a collection of samples that a future mission can come and return to Earth, answering some of the most fundamental questions we have about the planet Mars and the potential for life beyond Earth in our solar system. And so those are kind of the main 3 objectives of the mission, and much of the mission is designed to support those 3 objectives. And then, of course, as I mentioned, we are also using this rover to prepare for humans. And we have some exciting technology demonstrations on the rover that are moving us towards that particular aim. Here's the rover. It may look familiar to you if you've seen pictures of the Curiosity rover. They're very similar. They are twins in a way. A lot of heritage engineering in the Perseverance rover based on the design of the Curiosity rover, but with a new and updated instrument science payload. So some familiar instruments on this rover, including cameras that are similar but upgraded compared to Curiosity's cameras, as well as the laser on the rover, which analyzes the composition of soils and rocks on the surface of Mars. On Curiosity, we have an instrument called ChemCam, but the version that we carry on Mars 2020 is basically 4 instruments in one, so really deserving of the term SuperCam. We carry a weather station called META, and each of these is an acronym, many of which I don't even remember. But META is the weather station, so it measures temperature, pressure, wind speed, and is basically the weather station that we have. So we get weather updates every day from the surface of Mars. Some of I mentioned the technology demonstrations on the rover, and these are instruments, but with kind of an eye towards demonstrating technology for future missions, is the MOXIE instrument. And MOXIE down here is one of those instruments contributing to human exploration. It can actually take carbon dioxide from the Martian atmosphere, which is mostly made of carbon dioxide, and it can convert it into oxygen. And this is a capability that future human explorers to Mars would really take advantage of in support of their habitat, but also creating the rocket fuel that would get them from Mars back to Earth. So this is a demonstration of that technology on a much smaller scale than human explorers would do. But we've actually run MOXIE several times on the surface of Mars, and we have successfully demonstrated the creation of oxygen on the surface of Mars. Some of the brand new instruments that this rover carries compared to previous ones are RIMFAX, which is a radar that can penetrate under the surface of Mars and resolve some of the interesting geology in the subsurface, so underneath the rover. And that's really useful in building the geologic context and story of how the rocks were deposited. We have the arm of the rover. This is the robotic arm, and it has a very large turret. I actually held a model of it in the Mars yard at JPL a couple of weeks ago, and it is big and very heavy. So it's a pretty strong arm. But on the end of the arm, we have the drill that will collect those samples that I mentioned. But it has 2 science instruments, Sherlock, which also has a camera called Watson, and Pixel. And Sherlock and Pixel are able to create maps, very small maps, size of a postage stamp, but can actually map composition, minerals, and organic matter on the surface of Mars in these little postage stamp areas. That's exactly the same kind of analysis that we would do to search for biosignatures in rocks on Earth. And so instruments that formerly were only in labs here on Earth are now on this rover on Mars, doing the kind of science that we would do here on Earth to search for signs of ancient life. So really exciting. And I think I have in my next slide an example of the kind of data that Pixel and Sherlock, those 2 instruments on the arm, are able to obtain. So here on the left, I'm showing what one of the cores looks like that Mars 2020 and Perseverance can collect. And this is the drill bit here, and the tube. It's actually about that size. And the mass of the cores is about that of a golf ball. So pretty small and about the size of your pinky. So small rock cores, but a lot of information can be encoded in each one of these samples. And on the right side, we're showing an example of something that if we found this on Mars, we would be absolutely thrilled. That's probably an understatement, because this is an example of a 3.4 billion year old fossil microbial mat from Earth. And when you use the Pixel and Sherlock instruments, these are Earth prototypes of those instruments, on one small area of this ancient microbial mat, you can see the distribution of elements, minerals, and carbon that suggests that life might have had a role to play in forming this particular rock. And the reason we know that is because we see concentrations of some of these elements and minerals in a way that would be unexpected if this was just a rock deposited by abiotic processes or without the influence of life. And we see concentrations of organic carbon in alternating layers within this rock, which we know based on this interpreting these kinds of maps basically represent the microbial mat as it grows over time and has to compete with sediment that's always trying to bury it. So we see these concentrations of organic carbon representing that ancient fossilized microbial mat. So it's exactly this type of thing that we are looking for on Mars and that we hope to find. And we can use our instruments on the rover to help us identify possible biosignatures. Then we can sample those rocks and bring them back and look at them up close and personal here on Earth. All right, so I mentioned that Mars 2020 and the Perseverance rover is part of the Mars Sample Return campaign. And so at the present time, this is still an architecture that is in work with international partners, including the European Space Agency. But here we have Perseverance as the first step. It's going to collect samples. Down here, this is one of the future missions. We have a sample return lander along with a
Katie,
rover.
Can I interrupt you briefly?
Yes,
looks like we have
absolutely.
a hand raised.
Okay.
Go ahead, Thomas Smith. I just allowed you to unmute yourself.
I think, Stacy, that's okay. Just keep
it's
going.
Okay. Okay.
Yep.
All right. Sounds good. Go ahead, Katie.
Okay, yes. So we have, along with the sample return lander, would ride along a small rover that we call the Fetch rover, whose job it would be to go and collect and pick up those samples. Sorry, was there another question? No, maybe not. Just some background noise. And once the Fetch rover collected those samples, it would shoot them off the surface of Mars in a Mars ascent vehicle that would then rendezvous with an orbiter and eventually get those samples back to Earth. So it's a complicated set of missions, but we know how to do each one of these in pieces. So this is something that we're looking at in kind of the 10-year time frame to get the samples back to Earth. All right, so I mentioned that, and we saw already the picture of the Mars helicopter Ingenuity flying along with Perseverance, and this is an artist's conception in the background, but I'll show in just a couple of minutes some graphics that show Perseverance or Ingenuity in flight. But I wanted to show this image here on the lower right, and you can just see these are the blades of the Ingenuity helicopter when it was installed in the belly of the rover. And here's that main square body that you can see here in the illustration. So this was the configuration that the helicopter was in when it journeyed to Mars, but we have since deployed it and it is flying on the surface of Mars actually in just a couple of days. We've flown it several times already, and its next flight is coming up soon. All right, so I wanted to talk about the landing site of the Perseverance rover. This is Jezero Crater. And this is an orbiter image that we've taken with a satellite going around Mars. And you can see the outline of the crater here. It's about 50 kilometers in diameter. And what was so special about this particular crater is this feature here, which is an ancient delta that formed when this river channel, which you can just see over here on the left, entered the crater and deposited sediment in a delta. And deltas form when rivers enter bodies of water. And so we know that there was a standing body of water here in Jezero Crater, and that the entire crater filled up because we have a channel going out the other side of the crater that indicated that this crater basically filled up and then spilled over. So this is the great kind of place to look for evidence of ancient life, since lakes here on Earth are teeming with life. And so if conditions were similar on the surface of ancient Mars, this would be a good place to look for life too. So in addition to the potential for surface environments capable of supporting life, we also have evidence for interesting minerals in the rock, suggesting that there could be habitable environments in the subsurface with these rocks in these subsurface environments now exposed at the surface. And we think that these rocks here in the crater are between 3.5 to greater than 4 billion years old. So studying the rocks here in Jezero Crater and on Mars give us a window into a period of time in the solar system history that's actually not really well represented in the rock record on Earth. And that's due to plate tectonics and the fact that we're constantly recycling the crust of Earth. And so by studying Mars, we have a chance to learn about the evolution of the solar system in a way that we simply really can't do just by studying rocks on Earth. So Mars is a great place to learn more about perhaps even how our own planet evolved in addition to how Mars evolved. All right, so here we are. This is a zoom in of that orbital image. You can see the delta over here in the upper left in much greater detail. And this star right here is Octavia E. Butler Landing, named for the famous and acclaimed science fiction writer. And that is where Perseverance landed on February 18th of this year. And this is where we began the mission for the rover. And so I'll talk about this area and show you some of the data that we're getting down now. I wanted to show this image. This is one of those orbiter images, but this little speck right here, and it's taken in a very oblique view, but if you blow that up, you can actually see Perseverance while it was in doing its descent to the surface of Mars, and there you can see the parachute deployed, and that little bright speck right there is the rover in its back shell and in its capsule. And so this was an incredible shot to get. I mean, just imagining an orbiter taking an image of the surface at exactly the right time to capture the rover while it was in transit to the surface. So a truly amazing image. And this was another iconic image that we're adding to our set. This is a picture of the rover as it is being deployed from what we call the descent stage. And the rover was deployed on a series of cables in a system we call the sky crane. And so you can see these cables still attached when this picture was taken. And it was, in this image, basically traveled through this comm link right here. From the descent stage, actually went down to the rover. And once the rover landed on Mars, it sent this image back to us here on Earth. So another great image. You could see the plumes of dust as the thrusters were moving the dust aside, and Perseverance was getting ready to touch down. And this is another image from orbit showing Perseverance once it had landed. And I talked in the previous slide about the dust blowing away. And so that's the kind of butterfly shape you can see around the rover. These images are 25 centimeter per pixel images, so we can resolve the rover, and this is what it looks like. But those are the patches of Mars where the blasters blew the dust away. So we're seeing the clean rock surface there. All right, so this is our first color panorama that we took on the surface of Mars, and it was indeed the kind of desolate, rocky landscape that we've come to associate with the surface of Mars, and so that no surprises here. But we were very keen to begin investigating these rocks to understand what kind of environments they represent and whether these rocks might be capable of hosting ancient signs of life. So that we're in the process of doing that investigation now, and that's currently underway. This was one of the first rocks that we targeted. So this is a close-up. We have a naming scheme that we're using. We landed in an area that we informally have named for the Canyon de Chelly National Monument in Arizona, which is on Navajo Nation land. So we're naming our targets after Navajo terms in a partnership with Navajo Nation. So our very first target was aptly named Maz, which is the Navajo word for Mars. It was this flat rock over here. But perhaps more interesting from a visual perspective were these very holy rocks over here on the left side. And we're still working to understand exactly what those holes mean and whether they're a characteristic of the rock when it was deposited, or whether this is something that happened after the rocks were deposited and just simply being sandblasted for billions of years might create this kind of texture. All right, so I wanted to show you the helicopter. So once we landed on Mars, we did some initial checkouts, and then it was time to deploy the helicopter for the first time. So this is what you're seeing here are the blades of the helicopter moving for one of the first times we did this. And so the rover it dropped the helicopter, then it drove away, and here it is imaging the rover doing its initial checkouts. And so you can see those blades, they were testing the blades and getting ready to fly. So this next image is the helicopter actually going up, and then in just a moment it should come right back down. And so that was one of the first flights where it was just showing, yep, it goes up and then it goes down. So a really great moment for that team and that part of our team, and the first kind of aerial controlled flight on another planet. I think that was the designation that they got there. So really, really neat and really exciting that Perseverance was able to capture that historic moment. All right, but we're there for the rocks, really. So I wanted to come back to the rocks, and this was an area that we studied just very recently, just this past week. So we have more of these kind of grayish rocks with the red dust from the surface of Mars that Mars is known for, covering them. But this next image is from the Watson camera. So that's the camera on the end of the arm. And it shows the up close view that we are able to get. So we're going to zoom in here to this little patch, and I'll play this a couple times. And there's the rock, the dust-free part of the rock. And you can just see some purple splotches, purple and gray splotches. And we're working to understand what that means and what that might mean in terms of how the rock was altered or modified over time. and whether fluids like water were involved in altering the rock to give it those purple splotches. So lots of things for us still to discover, and we're still in the process of checking out our instruments. So as we check out each new instrument, we're able to learn more and more about the rocks. All right, so I'm going to close out here with just a taste of kind of what we have ahead and what we're excited about. So I mentioned the delta, and this deltas are great places to preserve organic matter. And again, deltas on Earth are teeming with life. You can think about the Mississippi Delta, the Amazon River Delta, really great places to find and concentrate organic matter. And where we landed, we actually had the opportunity to look at some of these features that we think might be remnants of a formerly more extensive delta in the crater. So we call these delta remnants, and we've got a series of delta remnants over here and then a couple over here. And we've been able to do some imaging of these delta remnants since they are about closer to us than some of the parts of the delta. So the next image I'll show you is from our landing site, looking off in this direction to a mound over here that we call Santa Cruz that we think might be a former delta deposit. And so this is what it looks like. It's a pretty impressive mound, and we can just start to resolve some of those rock outcrops that might represent those lake beds capable of perhaps having signs of ancient life and preserving organic matter. So it's unlikely that we'll visit this particular remnant, but we'll certainly do imaging of it. And as we get even closer to it, it'll be quite impressive, I think, in our mosaics. And so looking forward to learning more about the delta and lake deposits in Jezero. And then we'll take a look over to this one. This is the Kodiak Delta remnant. And there's actually a chance that we may visit this one. And so we are interested in getting a kind of first look at it. And this is what it looks like. And so this made me very excited. As Stacy mentioned, I like sedimentary rocks. And so this is certainly sedimentary. We have beautiful layers preserved in these resistant parts of the outcrop. And you can just make it out here, but these beds are actually tilted and dipping, which is very characteristic of delta deposits as they build out into a lake. And so there is, really no doubt that we are looking at a delta deposit, which we expected since we knew there was a delta in Jezero, but really some fantastic rocks to look at and to build a story of the history of this crater and how it might have been capable of supporting life. So we might head to Kodiak in the future. And so this is a potential exploration target that we're interested in. And of course, in the foreground, what's interesting about this as well is that you see lots of big dark gray rocks, but are very different than the rocks we have here in the delta remnant. So there's a story and a history here. And our job is to try to piece it together and figure out, well, how did these rocks relate to these rocks in the delta remnant, and which one might have been habitable and which one might have signs of ancient life or might tell us more about the history of water and surface environments on Mars. So that's our job as part of the science team. And so we'll be doing this in the future. So once we are ready to hit the road, because our main focus is getting to the delta and then potentially in the future getting beyond the delta, maybe even exploring outside the crater. So here we are on Octavia E. Butler Landing, and we have two choices for how to get to the delta. We have a clockwise route along this purple path, and then we have a counterclockwise route. And as often happens, the purple route is maybe more interesting geologically, but it'll take longer to do it. The blue route is kind of like that boring interstate you might drive, but not a lot of interesting stops along the way. But ultimately, if our desire is to get to the delta, it may be worth it to take the quicker path there because we've got some really, really interesting rocks that we'd like to explore here in the delta. Also, we're excited about some of these deposits over here on the inner margin of the crater, basically this kind of bathtub ring on the inside of the crater where we might have these shallow lake deposits that again are prime locations, at least on Earth, for preserving signs of ancient life and maybe even those microbial mats like the ancient one I showed from Earth. So that's what the future of the mission looks like, and we have hopefully a long mission ahead of us, and we're just getting started, but already exciting results and lots of sedimentary rocks in our future. So I'll be very happy about that. But every new image we get from Mars is just another exciting data point and looking at a new patch of the solar system that no one's ever seen before. So it's been a great experience thus far. The mission is going really well. And you can stay tuned for a lot of exciting discoveries in the future. So